Hello and welcome to this video. In this video, we will deal with problem number 21 to 30 of arithmetic progression. So let's get started. 21st problem says that find the first negative term of the sequence 2000, 1995, 1990 and so on. So as always, pause the video here and try to solve the problem on your own. It's a simple problem. So let's get to the solution. So from the given sequence, we can determine that A is 2000, the first term, and D is 5 as shown, because 2000 minus 1995 is 5 and 1995 minus 1900 is also 5. Now we are supposed to find the first negative term, so we write the formula for nth term. A plus n minus 1 into D should be less than 0. Now substituting the values, we have 2000 plus n minus 1 into 5 less than 0, which gives us minus 5n plus 2005 should be less than 0, which evaluates to n greater than 401. So the next integer which is greater than 401 is 402. So 400 second term will be the first negative term, and we substitute it back for the formula of nth term. So 2000 plus 402 minus 1 into 5, that gives us minus 5. 22nd problem is how many terms are identical in two arithmetic progression 2468 up to 100 terms and 369 up to 80 terms. So this is a different type of problem, and let's see how we approach it. We assume that our terms are identical. Now if you look at the sequences 2468 and 369, then the sequence of identical terms will be 6, 12, 18 and so on. So the first term becomes 6 here, and the common difference becomes 6. Both are 6. So TR is A plus R minus 1 into D, which is 6 plus R minus 1 into 6 is equal to 6R. Now the 100th term of the first sequence will be 2 into 100 minus 1 into 2, which is 200. And the 80th term of the second sequence will be 3 plus 80 minus 1 into 3, which is 240. But rth term which we have to find, that is r we have to find, the rth term of the sequence cannot be greater than 200 because that comes from the common value. So the common value cannot be greater than 200. So 6r, which is the value of tr, should be less than or equal to 200, and r should be less than equal to 33 1 by 3. So the maximum value of r in this case can be 33. Therefore, we have 33 terms as identical number of terms in both the series. 23rd problem is find the number of all positive integers of 3 digits which are divisible by 5. This is a simple problem. So smallest 3 number divisible by 5 is 100 and largest is 995. So we have A is equal to 100, D is equal to 5 and Tn is equal to 995. We substitute that into the formula for Tn and we arrive at the value n is equal to 180. Now next question is 105 a term of arithmetic progression 4, 9, 14 and so on. In this case, our first term is 4, A is 4 and D is 5, because 9 minus 4 or 14 minus 9 is 5. We assume that 105 is the nth term of the arithmetic progression and we substitute into formula. So 105 is equal to 4 plus n minus 1 into 5, which is equal to 105 is equal to 4 plus 5n minus 5. 4 minus 5 becomes minus 1. When brought to the other side, 105 plus 1 gives us 106 is equal to 5n. Now in this case, 106 by 5 will not be an integer, so the value of n will not be an integer, and therefore 105 is not a member of the given arithmetic progression. Next question is find the first negative term of the sequence 999, 995, 991 and so on. This problem is similar to the problem we have just solved, and we follow similarly and we arrive at the answer of -1, so you can read it and do it yourself. Now this is also similar to the problem which we have just solved to find the common number of terms. So in this case, our series is 3 plus 5 plus 7 and 4 plus 7 plus 10. Both are continued to 100 terms. In this case, your first term is 7 and your common difference remains 6. So last term of the first series is 201, last term of the second series will be 301. So clearly Tn should be less than 201, and by substituting the values we arrive at n is equal to 33 again. Now 27th problem says that if m times, sorry about the spelling mistake there, if m times the mth term of an AP is equal to n times the nth term, find the m plus nth term. So this is a different kind of problem, and let's see how we solve that. So we assume that A be the first term and D be the common difference as usual. So given that n into Tn is equal to m into Tm. Now we substitute for the values of nth term and mth term, we arrive at n into a plus n minus 1 into d, and which is equal to m into a plus m minus 1 into d. Now we multiply and exchange the terms to arrive at the value a is equal to minus m plus n minus 1 into d. Now Tm plus n will be a plus mn m plus 1 minus 1 into d. Sorry, that should be d, not 0 at the last line. Now we substitute the value of d from the previous equation, and we arrive at a minus a equal to 0. I'll correct this last line here in the slide before putting it to GitHub. Next problem says that if a comma b comma c be the pth, qth, and rth terms respectively of an AP, prove that a into q minus r plus b into r minus p plus c into p minus q equals to 0. So in this case, we assume that x be the first term, d be the common difference of AP. So pth term is a equal to x plus p minus 1 into d. Qth term is b equals to x plus q minus 1 into d. Tr is c, which is x plus r minus 1 into d. By subtracting the respective terms, we arrive at the values for a minus c, b minus a, and c minus b. Now we substitute these values into rearranged terms of the equality which we have, and we arrive at the solution. Next question is find the number of integers between 100 and 1000 that are divisible by 7 and not divisible by 7. This is again a simple problem. The first number between 100 and 1000 which is divisible by 7 is 105, and last number is 994. Therefore, we have a is equal to 105, d is equal to 7, and tn is equal to 994. Substituting for the formula of tn, we arrive at the solution of for n, which gives us n is equal to 128. Now this is the number of numbers divisible by 7. Clearly, numbers not divisible by 7 will be total numbers minus numbers which are divisible by 7, which gives us 771. Now 30th problem is if a, b, c be the ph, qh, and rh term respectively, then we have to prove that a minus b into r plus b minus a into p plus c minus a into q is equal to 0. This is similar to problem number 28, which we have just solved. So we just substitute the values for a minus b, b minus c, and c minus a this time without interchanging them. We arrive at the solution to be 0. So these are the problem number 21 to 30. In our next video, we will solve problem number 31 to 40 of arithmetic progression. Now, if you like this video and you find this informative, please like the video and subscribe to the channel for many more videos to come, because we are going to cover the entire mathematics syllabus for class 12. Thanks a lot for watching. Enjoy.